Hello, in this video we'll be looking at the experimental methods to find the specific latent heat of fusion of water. Okay. In other words, we'll be trying to find out how much energy it takes per gram to melt ice, or if you use SI units, the energy required per kilogram to melt ice. Okay. Now there are two methods. One is by using a heater. One method will be using a heater, and the second method we'll get round to looking at is we'll be melting in water. Okay, so those are the two methods we'll be looking at, and the first method we're looking at is by how we try to calculate specific latent heat and fusion of water using a heater. So now, first of all, let me remind you of the equation. The equation we require is Q equals mL, where Q is the energy transferred, M is the mass, grams or kilograms, and L is the specific latent heat. So I've got latent heat. The other equation we need to look at is that the energy transferred into it, the electrical energy put into the heater, E, is equal to the current in amps I, the voltage V, times the amount of time in seconds in which the heater was switched on for. And in our experiment we'll find that the energy transferred will be equal to the energy supplied from the heater. So, first thing we need is we need some ice, of course, and we're going to have melting ice. And melting ice means that the temperature is at 0 degrees C. So we're going to have to assume the ice is at so the ice temperature we're going to assume is 0 degrees Celsius. And what we need is we need to have a setup similar to this. What we're going to have, we're going to collect some ice, and we're going to put it into a filter funnel, like that. So this is, and into that filter funnel, like that. And we want a mass there. Let's call that mass A. We also want another filter funnel with exactly the same amount of ice in, but this time in it we'll make ourselves a little heater. So we've got the same amount of ice in here, and then we'll have a heater, and we'll collect the water from both. So this is mass A of ice. This is mass, rather no, what I meant was, so the mass of each ice is the same, but what we're going to measure is the mass of the water collected once it's melted. So this is mass A of melt water, and this will be mass B of melt water. So why have we got two? Well, the whole idea of the experiment is to add energy into there, and once we know how much energy we put into there, we can calculate how much energy was used to melt a certain amount of water. But of course, it's not only the heater that's going to be melting the ice; it's also the surroundings. So this is, if you like, this one here is the control. So it's amount of ice without heater. So therefore, we know what's being melted by the surroundings, and the difference between mass A and mass B will give us the mass of ice melted just due to the heater. So let's set up the experiment now. So we will have, here is our control, mass A. Here will be our sample, the same beaker, to be heated, that's be melted. So this will be the mass of meltwater B. So there'll be some ice in here, and also in here we'll have a heater. Okay, that's a terrible diagram. Let's try again. Wire with coils, our heater, and our heater will be connected to a power supply, positive, negative. In here we will have an ammeter to measure the current, and across the heater we will have a voltmeter. We'll also have a clock to measure the amount of the time. Okay, and also there in here there'll also be the same amount of ice there as we have in there. So we'll turn it on, and what we'll do is we'll time how long we've turned the heater on for, and then we'll have our two different masses of water and time. So what we'll be measuring the voltage recorded in volts. We'll be measuring the current in amps. We'll be measuring the time in seconds, and also we'll be finding out the mass of A and the mass of B, which will give us the mass due to melted water M equals, if you like, the mass of B minus the mass of A. And we'll get those values there, and we'll then put them into the equation. Let me get rid of space. We'll put them into equation Q equals L to find out what L is. So how do we do that? Okay, so I'll rub this out. So what we will have is the difference, the energy, so Q will be equal to I times V times T, will be equal to the mass difference between mass A and mass B, which is M times the latent heat of fusion. So the specific latent heat of fusion of ice will be equal to current times voltage times time divided by the mass melted purely to the heater. And we've got to make sure that if we're finding the specific latent heat of fusion of water, in grams it should be in joules per gram, and if we use kilograms it must be in joules per kilogram. Our final answer for latent heat of fusion.